Let's start, guys. So hopefully this is one of the last log lessons. We might do a few more, one more log lesson, just so you guys can see it in action. So now we're just solving for x. We're just solving. So here we go. I'm trying to solve for x. My first move. Look at the first one. They give me some instructions here of what they want. It says leave answers as whole numbers, fractions, or radicals if they cannot be evaluated. No exponents or decimals. Okay, so no exponents or decimals. First move. I'm trying to solve for x. Move the 5. Minus 5, minus 5. 12 log base 2 of x equals negative 18. Can we do that? Next move, I'm trying to solve for x, so I got to get rid of that 12. How do I get rid of that 12? Hey, no yawning. It's early now. Divide by 12. Log base 2 of x equals negative 18 over 12, which this in itself reduces. Yeah, 6 goes into 18 3 times. And yeah, 6 goes into 12 2 times. So log base 2 of x equals negative 3 over 2. Are we still okay? All right, so here we go. Turn this, well, remember, we're trying to solve for x. Turn this into an exponential. 2 to the power negative 3 over 2 equals x. You're already winning. You already won. This is why I put on delta the optional exponents. If you're having issues with exponents, you're going to have issues here. I turned this into a positive by bringing it down. Chop, what do you mean bring it down? There's nothing in the bottom. That's like something over 1, right? When I bring this whole thing down, then I get this. 1 over 2 to the 3 halves equals x. Are we okay? Yeah, if we're having trouble with exponents, guys, please come in or work on that delta math, the optional assignments. Okay, now what? Look what it says here. It doesn't want any fractions or radicals. Let's see, or leave answers as whole number fractions or radicals. It does want fractions, but it doesn't want exponents. Look, it says no exponents. At the moment, will it take this? No, I have an exponent. So that 2 down there in the denominator of that exponent is square root, and that 3 means 2 to the 3rd power. So it means this. 1 over the square root of 2 times 2 times 2. What can I take out? Yeah, a pair of those, right? Every time. That, do you guys know what I mean? Okay, so here's my final answer. You don't have to do it. Maybe I made it more complicated. X equals 1 over 2 square root of 2. Maybe I made it more complicated. Maybe I should have just said 2 to the 3rd power is 8. And then say that's 4 times 2, and then the square root of 4 is 2. 1 over 2 square root of 2. Maybe I should have done that. So there it is. I did it all 3 ways. Here's the answer. 1 over 2 square root of 2. They didn't tell me anything about rationalizing it, so you can leave it like that. By the way, first period already did it, so it's fine. I helped them out, and you could leave the square roots in the bottom. Oh, the definition of square root, you're talking about this down here. You don't have to do it that way if you don't like it. The definition of square root, every time you have a pair, you take it out, and then this is the only thing you have left in the square root. Yeah, that's what I did over here. 4 times 2 is 8. The square root of 4 is 2, so 2 square root of 2. Just do that. Yeah, okay. You're going to have other powers on the delta, so that's why I just did it. But yeah, it's not a big deal. Question number 2. For whatever reason, question number 2 is easier. I didn't tell. By the way, this is just a handout created by DM. Here we go. Solve the exact value. Same thing. Move the 8 minus 8 minus 8. The difference between 6 and 8 is 2, but the 8's larger, so negative. So log base 8 of x equals negative 2. You don't have to put it. You don't have to do anything. You can just go right from that to that. Yeah, because that's showing the steps that you did minus 8 on both sides. Turn that to an exponent. 8 to the negative 2 equals x. Yes, this one's easier. Maybe we should have done number 2 first. I don't know. Bring this down because it's a negative exponent. So x equals 1 over 8 squared. Can I leave it like that? 1 over 64. Done. What do you think, Kyle? You're not entertained? All right. Question 3. There's a plus right in the middle. So product rule. Log base 3, giant parenthesis, 9x times. Oh. You see this 3 right here? Bring it up. So 9x times 4 to the power 3, close it, equals 0. That's the power rule with the logs, right? 4 to the power 3 is 64. There it is. 64 times 10 is 640. So 64 times 9, what is it? 576. Log base 3 of 576x equals 0. Yeah. Take 64 away from 640 and you get 576. All right, turn it into an exponent. 3 to the power 0 equals 576x. 3 to the power 0 is? And then to get x by itself, I just simply what? So there it is. 1 over 576. Three to the power 0 is 1. Anything raised to the power 0 is 1, always and forever. Except for 0 to the power 0, but that's a indeterminate form. Yeah. Anything to the power 0 is 1 except for 0 to the power 0, that's indeterminate form. In calculus, not in pre-calc. All right, here we go. I have a minus. So what do I do when I have a minus? So let me change this color to purple so it doesn't blend into with the other red. Log base 3, giant parentheses, 7x over 2, close it, equals 5. Now I'm going to solve for x by turning this into an exponent. 3 to the power 5, so 3 to the power 5, equals 7x over 2. Let's see if I can do 3 to the power 5. 3 times 3 is 9. 9 times 9 is 81. 81 times 3, oh, dang it. What is it? 243. Okay, I'm going to trust. 243 equals 7x over 2. Multiplied by 2. Whap, 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 whap. Multiplied by 2. So 7x equals 486. And then last move, divide by 7. X equals, and that does not reduce. Leave it alone. All right, let's go to the next one. There's a plus in the middle. I can just do, product. Log base 3, giant parenthesis, little parenthesis, 3x plus 5, close, open, x minus 7, close, close, equals 2. Oh, man. Okay. You're going to have to distribute. You're going to have to multiply. I know you can just scan this with AI, and AI will just give you an answer. Don't do that, guys. 3 to the power 2. Yeah, don't use PhotoMath. Don't use Google Lens. Don't use Wolfram Alpha. No, because you're going to have to do this by hand anyways. So just learn it, guys. 3 squared is 9. 3x times x, that's 3x squared. 3x, I'm foiling, I'm distributing. 3x times x. 3x times negative 7, that's negative 21x. Let me know if I make a mistake, guys. 5 times x, that's going to be a plus 5x. Okay. I turned it into an exponent. Right. 5 times negative 7, what's that? Negative 35. Combine like terms. 9 equals 3x squared minus 16x minus 35. Subtract 9 because you have a quadratic. You want to set it equal to 0 to solve, right? Yeah, we're done with the pre-cal. We've just been doing algebra since exponent form. You can divide by what? If it's factorable, I'm kind of tempted to just use the quadratic equation. It's probably factorable. It looks like it's probably factorable. You want to use the AC method, but I think the easiest route is the quadratic formula, guys. I think that's the easiest route. What did you say, Lazardi? How did I know what? How did I know this is factorable? It looks like it could be. There's something called the AC method. The numbers look pretty to me. So it looks to me like you could probably factor this out. But I'm just going to do the quadratic. Unless you want me to do the AC method and see if we can. All right. X equals 16 plus minus square root. I guess technically you cut up negative 16 there, but you're squaring it, so it goes away anyways. 4 times 3 times negative 44 all over 2 times 3. If you want, guys, I can do the AC method. Let me know if you want me to do it. Yeah, the AC method you would still have to do manually. So this is why I think the quadratic formula is probably better. You know what I mean? All right, here we go. Quadratic formula. I'm just going to plug in 16. I'm going to do the plus one first. Plus square root. And I know I had a negative 16, so here's your negative 16. It doesn't matter because I'm going to close it and put a square anyways. Minus 4 times 3 times, what was it, negative 44? All over 6. 2 times 3. So here's my first answer, 22 over 3. X equals 22 over 3. And then let me change the plus to a minus. Enter, push math, bless you. Math, frac, enter. But if you do it like this, it comes out as a fraction already. Negative 2 is the other one. All right, hold on. Don't, guys, we're not done with this one. Remember your domain. Which one can it not be? Yeah, it can't be negative 2 because you can't have a negative inside your argument. And if you wanted to, you can test this one out. It is going to work. Plug in a 23 over 3 into x. Do you guys want to see that? Okay. You guys. Yeah. If you plug in a 22 over 3 in for x, and you'll get your 2 there. All right, let's go to the next one. We're halfway. All right, guys. Focus. All right. Here we go. There's a minus. No. There's honey right there, and there's apples over there. Just grab some. All right. Log base 7, giant parenthesis. 2x squared minus 5 in the numerator. 3x plus 4 in the denominator equals 0. Yeah, all I did was the property, quotient log property. Next, turn it into an exponential. 7 to the power 0. What's that? 1. So 1 equals this. 2x squared minus 5 over 3x plus 4. Are we still okay? All right. Multiply the right and the left by 3x plus 4. Whatever you do to one side, do to the other. Times 3x plus 4 times 3x plus 4. Yep. 3x plus 4 equals 2x squared minus 5. I have a quadratic. Move your linear part, whatever you have on the left-hand side of the equal sign, move all that to the right. 0 equals 2x squared minus 3x, and be careful. Negative 5 minus 4 minus 9. You could use the quadratic equation, but this one, unlike the other one, looks simple enough to factor, if it's possible. And it looks like I think this one is. What's up? You can always use the AC method and see if you can group factor by grouping once you expand it. But this one looks easy enough to do like a guess and check. And no, Yanni, that's a demerit. What? That's a demerit. 2x times x. Chav, how'd you get that? There's only one way to get 2x squared. 2x times x. I see this 9. There's 2 ways to get 9. 9 times 1 and 3 times 3. Which one looks more exciting? Yeah, so I would try that one out first. 3 and 3. Notice that it's a negative 9. So that means one's positive, one's negative. So let's put the negative on this one and the positive on that one. Chav, how did you know? Because I'm trying to add up to a negative 3x. You guys see that? So when I distribute 2x times negative 3, that's a negative 6x. 3 times x, that's a positive 3x. So negative 6x plus 3x is that negative 3x. Do you guys see that? So there it is. It works. That's called the guess and check method. There's also another one called AC. And that's demerit number 4 over there for you guys. X equals 3. X equals negative 3 over 2. So catch up to here. One of them is going to work. One of them is not. Which one's not going to work? The negative 3 over 2 will not work. You can have a negative x value, but you cannot have a negative inside your argument. When I plug in a negative 3 over 2, you will get a negative. Yeah, look. You get a negative 9 over 2 plus 4. That's still going to be negative. No, that's not. Okay, time out. X can be negative. The inside the argument, this in here, cannot be negative because remember, guys, what you guys told me from your Algebra 2 days, your domain is all numbers larger than 0.
So let's say like it was 3x minus 100. Could the negative 3 over 2 be answered?
No, because you're subtracting 100, so you're going to get a negative answer inside the argument. You can have an answer that's negative, but when you plug it into your argument, the argument needs to be positive. You guys know what I mean? Like you can have a negative 5 as an answer, but once you plug the negative 5 into the argument, as long as the argument is positive, you're good. Or just test it with your calculator, and you'll either get a false or true. It's possible both could be the answers, but in this one, only the 3 works. See, the 3 will not get you a negative inside the argument. Okay, Lazardi? Okay. All right, this one right here, guys. I don't know if you've ever seen this before. This might be 100% new to you. They should have done a better job with showing what's the base. I guess they did do an okay job because they made that font smaller. All that is the base of that log. So negative 2x minus 2. So we're gonna square that in a little bit. So we're gonna solve for x. So obviously if we get an answer or two, it's probably gonna be all true, right? Because that's what's making that base. Okay, I'll stop. Let's just solve this. So here we go. So negative 2x minus 2 raised to the power of what? 2 equals 3x squared minus 2x minus 20. Catch up to here. Then we're gonna square this in the inside. Negative 2x times negative 2x. Positive 4x squared. Then I'm going to have negative 2x times negative 2. That's positive. Negative 2x times negative 2 is a positive 4x. You're going to have 2 of those. So positive 8x. Does everyone see where I got the 8x? Okay. And then negative 2 times negative 2. There it is. The 2x minus 2 squared gives you that. Equals 3x squared minus 2x minus 20. Are we okay so far? I'm going to move everything to the left because I want to have the x squared be positive. So minus 3x squared plus 2x plus 2x plus 20 plus 20. So here's what we're going to have. X squared plus 8, 9, 10. 10x plus 24 equals 0. Are we still okay? Yep, now we're going to factor out. Perfect. They're making it easy for us because it is a 1x squared. So what times what is 24 that adds up to 10? There it is. X plus 6, and they're both positive. X plus 4. Now, those aren't my answers, positive 6 and positive 4. But they're almost my answers. Some of you might be able to see like 2 or 3 equations ahead and just type in x equals x equals. All right, my 2 answers. Negative 6 and both of them will work. You can try them out if you want. Oh, no, well, okay. Check it out. Remember, you're looking for bases that are always going to be positive. You can already see it right off the bat. Negative 2 times negative 6 is a positive 12. Minus 2 is still positive. Negative 2 times negative 4 is a positive 8. Minus 2 is still positive. So as long as your base is positive, you got it. Both of them work. And both of them work on the inside of that too. That's 3x squared, so it's going to be negative 6 squared, 36. 36 times 3 is already a big number, quote unquote. All right, here we go. Let's try round 2. You ready, Mia Cruz? You should give some of these questions to your boy, miss. No, I don't mean it like that. Yeah, it's on YouTube. It's mark the 244 mark. Hello, sir. I mean this with love, I promise. It's all, just because, couples that study together stay together. So there it is. All right, here we go. Yeah, I wasn't talking smack. All right, here we go. Well, yeah, no, I have so many flaws. 2x minus 5 to the power 2, I'm recording, equals 3x squared plus 7x minus 15. Is everyone okay? Haven't done anything crazy. All right, here we go. What? Well, I just got it from here, miss. You can just look into your paper. Negative 2 times negative 2x. 4x squared. Negative 2x times negative 5. That's going to be a positive 10x. 2 times 5. Positive 10x, and you're going to have how many of those? So it's going to be plus what? 20x. Negative 5 times negative 5. Plus 25. Are you okay, Lazardi? Okay. Move everything to the left. To the left, to the left. So minus 3x squared, minus 3x squared. So that's x squared. Minus 7x, minus 7x. So that's going to be what? 13x. Plus 15, plus 15. 40 equals 0. They're being nice again. They're being nice. Chav, what do you mean they're being nice? Anytime they put a 1 in front of that x squared, it makes life a lot easier to factor. Two numbers that when you multiply give you 40, but add up to a 13. 8 and 5. X, yeah, of course she's smart. X plus 8, x plus 5. So that means my both answers are negative 8, yeah, negative 5. Let's see, do they both work? Negative, negative. Yeah, they're both going to work. They both work, so both will be the answers. Cool or not cool? All right, here we go. A lot of first period thought that these were easier. I don't know why. So when they did the delta math, they went right to the last topic because they thought that was the easier one. All right, here we go. First move, I'm solving for x. So what's my first move? Subtract 12. So 4 ln of 7x plus 3 equals 28. Are we still okay? What's the next move? I got to get rid of that 4. That's 4 times ln. Divide by 4. ln of 7x plus 3 equals, what's 28 divided by 4? 7. Now, eventually, once you do a whole bunch of these, you're gonna start skipping a step. I like to just say E and E, but we're not there yet. I don't think we're there yet. We're probably you're probably 20 questions away from being able to do it comfortably. Turn this into log. Log base E of 7x plus 3 equals 7. Now, e to the 7th power. Yeah, eventually we're going to skip this middle step there and just go right into that, EE. You can, if you feel comfortable. If you feel comfortable, we can just go EE. See? And then the E and ln cancel each other out. 7x plus 3. Drop it out. 7x plus 3 equals e to the 7th. You can if you want. All right, next. Move the 3 to the other side. So e to the 7th minus 3 equals 7x. Divide by 7. So here's my final answer. E to the 7th minus 3. All that divided by 7 equals x. Done. All right, let's go to the next one. Number 10. What's your first move? Add 2. 6 ln 4x minus 10 equals 42. What's the next move? Divide by 6. ln of 4x minus 10 equals, what's 42 divided by 6? 7. You could, if you feel comfortable right here, you can just go e raised to that, drop it, then drop it like it's hot. 4x minus 10 equals e to the 7th. If you don't feel comfortable, just go log base e of 4x minus 10 equals 7. Here we go. Turn it into an exponential. E to the 7th equals 4x minus 10. What do? Plus e to the 7 plus 10 equals 4x. And then what's the last move? Divide by 4. E to the 7 plus 10 divided by 4 equals x. There it is. Can we do this, guys? All right, guys. Log into Delta. Take care of the business, and we're good. No, that's yours.